Alright, so in this video we do some examples of position and velocity problems, and specifically we try to transition from what we've done in the past where we've talked about a function f and that function's derivative in terms of increasing and decreasing. Okay, so for example, we know that if you look at the derivative is equal to 0, that will tell you when you have a critical value. When you have a critical value of the function f. And once you find that critical value or critical number, you could put that on a sign line for the derivative, and you could determine maybe that this is what your sign line comes out to be. When the derivative comes out to be a positive number, this is where we say that the function will be increasing. So when the derivative is positive, we know that the function is increasing. And that comes about because if we have a function like this, for example, okay, here is our critical number c, a place where the derivative is equal to 0. Okay, when the derivative is positive, that means that the slope of the tangent line is a positive number. So we've talked about the geometric interpretation of a derivative. And when the derivative is positive, the function is increasing. And when the derivative becomes a negative number, right here, that means that the function is actually decreasing. Okay, so this is where we have come from, and what we need to do in the next videos is to talk about position and velocity. Position is a function of time, is playing the role of our function, and the derivative of the position function we're calling velocity. And we could do the same kind of thing here. We could look at when the velocity is equal to 0. This will be a critical number of the position function. And then we can make a sign line for the velocity. Put your critical number on here. And when we get the same positive and negative, we can say that when the velocity is positive, that means that our position, that our object, we can say that when the velocity is positive, we'll say that the object is moving to the right. Okay, and when the velocity is negative, we can say that the object is moving to the left, right? And when at the critical number, the velocity is equal to 0, so the object has stopped, instantaneously stopped for a moment, and then the velocity will become positive or negative, and the object will move to the left or to the right. So with this particular transition in terms of terminology from functions and derivatives to position and velocity, we can now look at an example. Okay, and this is an example of a rectilinear motion problem. And we can see here that a position function has been given to us. Okay, so we have a position function being 2t squared plus 8t minus 7. So here's our position function. Okay, so for example, you might notice that at time t is equal to 0, our position is equal to minus 7. Okay, so we have an object, okay, that's moving in rectilinear motion. We're going to have an object, we'll just call it a dot, and that object will be moving left or right along this line. Okay, so we can say that left is negative and right is positive, and 0 will be right here in the middle. So at time 0, we have an object that is starting at negative 7 units to the left of 0. Okay, we can see that the velocity at time t is equal to 0, the velocity, which is the derivative for t plus 8, that the velocity at 0 is a positive 8. So we can see that the velocity here would be an arrow pointing to the right. So our object is going to start at position negative 7, but the object is going to be moving to the right. Object moves to the right. Now we can see that that kind of makes sense because at time t is equal to 1 second, we can see that the position of the object at 1 second is 2 plus 8 minus 7, which is equal to 3. So at time t equals to 1 second, our object is 3 units right over here at t is equal to 1. So to go from -7 to 3, we did have to move to the right, which is what our velocity being positive was telling us. Okay, so if you look at the velocity at 1, right, which is 4t plus 8, right, we can see that the velocity at 1 is equal to 12, and at this particular moment the object is still moving to the right. Okay, so the question is, does the object ever stop? Does the object ever stop and try to reverse direction? So it seems like this object is moving to the right. It's moving to the right. Will the object ever come backward to the left? Does it ever come back to the left? And we can figure that out by looking at the velocity graph, which is 4t plus 8, and asking when does that equal to 0? And we can see that the velocity never equals 0, for t being a positive number. Okay, so if we allow ourselves to move positive in time, that the velocity never equals 0, so this object is always on a one-way trip out. It's always moving to the right. Okay, we can see what that might look like here. Let me bring in our little graph of our pong paddle, so to speak. And if we put in the position function, 2t squared, 2 times t squared plus 8 times t minus 7. And if we just plot this for like 2 seconds perhaps, see what happens in that range. Okay, we can see that the object started at -7, okay, as promised. Okay. And then as time goes on, the object is moving to the right, and the velocity is always a positive number. So this object is always going to move to the right until it finally goes off the screen. And if we wanted to plot for more time, you can see that this object is just going to keep traveling to the right. Okay, so that is a position and velocity problem. We have determined that the intervals on which the object is moving to the right, that this object is moving to the right for times 0 to infinity. When does the object reverse direction? We would say never. When is the velocity of the object increasing, and when is the velocity of the object decreasing? So at that point we would need to go to the derivative of the velocity, which is equal to the derivative of velocity, which would be equal to 4. So we can see here that the derivative of the velocity is positive, so the velocity of the object is always increasing. That is the derivative, the rate of change of the velocity is always 4. So this object is accelerating, which is the derivative of velocity, has a constant acceleration. And draw a figure to illustrate the motion of the object, and use a graph to illustrate the velocity of the object. That's what we have drawn over here. So we can see that this object, might start at -7, and as time moves on, it seems to get faster and faster and faster moving. Okay. All right, so in this video, we'll try another one of the more complicated examples shown here where the object actually reverses direction.